Hey class, so continuing again with learning. So I'll give you guys a chance to watch a video about the introduction to logarithms. So as you can see now we're moving on to logs, which is lesson 22-2. We skipped 22-1 because it's an applicational part and not meeting physically is going to make it a little bit challenging. So let's just look at what logs are, and then from that we'll do some applicational problems. Um, so before we start with these learning targets about graphing it and all that, let me just talk about what logarithmics are, and then uh, a few examples. So uh, logarithms. That's good. So logarithms are just the inverse of exponents. So what do I mean by that? So we saw that for exponents we have this function. We're gonna keep it simple. Um, so in exponential we have something like this: y is equal to b to the x. Well, if I write this in log form, so we use log to talk about logarithms. So if you look at a calculator, scientific calculators, you see the word log, that's where it comes from, logarithms. So in logs, this is the same thing or equivalent to log base b of x, sorry, base b of y is equal to x. So they're equivalent. So log base b of y is equal to x. So for example, oops, and we'll keep it simple. We know that 3 to the second power is equal to 9. We know that for a fact. So this is an exponential notation. So if I write this using log notation, this is telling me, okay, so this is the same thing as log base 3 of 9 is equal to 2. So notice the way we write it. So 3 to the second power equals to 9. So here I'm saying log base 3 of 9 is equal to 2. So in the video, one way to that I share with you guys, one way to read this would be is like 3 to what power equals 9? Well, that power has to be 2. So that's how we look at them, both ways. So as we do this, I'm going to remind you to go back to this part right here, guys. This part right here, because when we're working with logs, I'm going to ask you visualize it as an exponential function. So for example, what happens if we have log base 2 of 5 is equal to sorry, not base 2 of 5. Actually, we do an exponential function then we'll do another one. So for example, let's say that 5 to the third power, that's going to be equal to 125. So if I write using log notation, this is the same thing as log base 5 of 125 is equal to 3. So you notice the differences. Notice where everything is located. So base, 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 power equals to the power, power equals to the power, and lastly, the final product. There it is, the final product. So notice the consistency. So again, it goes back to this right here. So that's the definition of logs, okay? So with that, we'll do some examples here. So again, I don't want to worry too much about the graph of this. I'll talk about that later, but I do want you to be able to complete some of the work um, in this section. A few things to remember that in logs, if the base is 10, we don't write down the log base. So I'll show you what that means. Again, so if the base is 10, we don't write down the base when we write the log. So for example, this is what it means. If the base is 10, do not write the base in log notation. So for example, 10 to the third power is equal to 1000. So if I write this in log notation, I would just write log base 10 of 1000 is equal to 3. So notice that I'm not writing a base anymore. So again, whenever the base is 10, we do not write the base in log notation. It's always understood that if you don't see a number for the base, it's always 10. So with that, that's what this is telling you. So sometimes you see in the calculator just the log button. The log button means that the base is 10. And then you see another feature where you can put a different base. So something to keep in mind. So with that, let's look at, and again, it's also here, see, when there's no, oops, when there's no base, it means because the base is 10, okay? So with that, I want to emphasize this type of problems right here. So look at number 3, 3A, it says, write the information in log statement on log form. So how would you write this logs, this expression, the exponential expression into logs? So again, this is the same thing as log, because the base is 10, I'm not going to write base 10 of 10,000 is equal to 4. Next one, again, the base is 10. So again, notice that the base is 10. So I don't have to write it when I write in log notation. So this is the same thing as log, base 10 of, and I like to put parentheses when I see a fraction, 1 over 10 is equal to -1. So again, notice that don't let the log notation confuse you. Just think of it as the exponential function. So this is the same thing as 10 to the power of -1 is equal to 1 over 10. This is the same thing as saying 10 to the power of 4 is equal to 10,000. So notice that in number 4, we're going the opposite now. They're giving us log notation, so write it in exponential form. So notice that the base that should be here, there's no number in there, so it means this has to be a 10. So the same thing as 10 to the power of 5 is equal to 100,000. So that's how I go back and forth. In the next example, if you want to try it first, pause the video and then try it. If you want to just kind of follow along with me, then do it. Again, notice that there's no number there, so that means that the base is 10. So 10 to the power of -2 is equal to 1 over 100. So with that, let me do a few samples for number 5, and then we'll come back to 5. So because now that you understand log notation, then it's kind of easy to think about, wait, how do I simplify this? So with a calculator. So think about this. So what happens if I'd say this? Um, 3 to what power, is equal to 81. So think about it. 3 to what power is equal to 81? And if you're saying, well, it's 3 times 3 is 9, 3 times 3 times 3 is 27, 3 times 3 times 3 times 3 is 81. There it is. So that means that this is the same thing as 3 to the 4 is equal to 81. So remember that I can also write this in equation form. 3 to what power? I don't know. I'm going to call it x is equal to 81. So that means that my answer has to be x is equal to 4. So then, so you see how you can visualize the exponent here if you're familiar with, with your multiplications. So the same thing here with the log. So let's say that I have, so this is in exponential form. So what happens if I have this in log form? So what happens if I write this in log form will be log base 3 of 81 is equal to something. I don't know what that is. So again, if you don't see it, go back and read this in this form. So this is telling me 3 to some power has to equal to 81. What is that power? The power has to be 4. Also, that means that this is equal to 4. So log base 3 of 81 is equal to 4. Just how we solved it here. Just like that one. So if I have a problem that says log base 2 of 32, and they ask to simplify this, think of it as an exponential function, exponential form. So this is telling me 2 to what power equals 32. So this is your job. Visualize it. In exponential form. So this is the same thing as 2 to some power has to equal to 32. So what is that power? Or 2 to the power of, I don't know what it is, I'm going to call that x is equal to 32. Okay, well 2 times 2 is 4. 2 times 2 times 2 is 8. 2 times 2 times 2 times 2 is 16. 2 times 2 times 2 times 2 times 2 is 32. Also, that means that x is equal to 5. So that means that here the answer will be 5. So again, going back to this question, so that's what they're telling us. So now, can you simplify this? So think about this. I know there's a base here. I don't see it. That base has to be 10. So it's the same thing as 10 to some power, I don't know what that is, has to equal to 1,000. Well, then 10 to what power equals 1,000? So again, 10 times 10 is 100. 10 times 10 times 10, there it is, 1,000. So that means that this is equal to 3. Okay. So I'll leave this one for you guys, and then you can finish it. But essentially, this is all there is. So I'm gonna stop here, and I'm gonna provide more videos too. But again, everything is base 10, and then we'll continue working with logs. So then, again, if you have any questions, remember Fridays. That's when you're able to look into the Zoom sessions, and then if you have any questions, you can always ask us questions. Again, more of you are submitting work, so I'll be submitting grades this week, and next week I'll be giving you guys more details about the final, how to improve your grade if you know that the classwork alone is not enough. So I'll give you guys details about how to get a better grade. Again, if you have questions, keep sending me those messages, and stay safe. I hope that everything is going well, that you're being more productive now that you probably got a better hang of how to live in this current situation. So have a good night.